welcome to another episode of I've Got Problems. Today we're going to be focusing on a kind of problem I call a rainbow problem. In order to solve a rainbow problem, you're going to need a set of numbers. There are two requirements for the set of numbers. Number one, they need to be based on some sort of a pattern. They're typically multiples of a number, but they can be based on other patterns. And number two, they need to be arranged sequentially, so either from smallest to largest or largest to smallest. Typically, a problem writer will take care of this for you, so you're not going to have to do it, but every once in a while they give you a jumbled set, and if you can recognize that the numbers come in some sort of a pattern and you can arrange them, it'll be to your benefit. Here are some examples of number sets that would work for rainbow problems. You could just have counting numbers. They're arranged sequentially from smallest to largest. You could have sets of multiples, for example, 6, 12, 18, 24. Again, they've been organized already. Or you might start with a number and then it counts up by a certain amount. So in this case, these aren't multiples of 9, but you started with 9 and then added 5 every time. Here's another example of a set that would work. It's just multiples of 4. Now I'm going to show you what I'm going to do with these numbers, and then you'll understand why it's called a rainbow problem. When you have sets of numbers that follow a pattern and they're arranged sequentially, if you draw an arc from the first number to the last number like that, and then add them up, you're going to get a certain number. In this case, 4 plus 28 is 32. If you then draw a new arc that connects the second number to the next to the last number and add them up, you're going to also get the same sum as this. So here that 4 plus 28 made 32, and here 8 plus 24 made 32. And you no doubt see that what's coming is 12 plus 20 makes 32. Now we've got this 16 left over, and a lot of times what I'll do is I'll just circle that because it makes it simpler. And now I know I have 3 sets of 32. So that's easy in my head to do. 3 times 32, which is 96. Then I have to add this 16 in, 96 plus 16. And if I can't do it in my head, that's okay. If I don't have the ability, or I just don't have the desire, then I can just quickly add it all up and I get 112. So just by thinking of the rainbow, it makes it really easy to add this set of numbers. 32 plus 32 plus 32 plus 16 makes 112. And it works with larger numbers too. Again, this is just counting in order from smallest to largest. If I draw my rainbow in, and I could change colors if I want, I certainly don't have to, but it does help keep it organized, I think. That's why I like to do it. And I've got one in the middle that's left over. So now, I've created my rainbow, and I can quickly see that 21 plus 29 equals 50. 22 plus 28 is another 50. 23 plus 27 is another 50. And 24 plus 26 is another 50. So I have 4 50s, which makes 200, plus the 25 in the middle, 225. And I've added those up lickety-split. Now sometimes you get a set of numbers that's something like this. You could draw the rainbow. You could connect the 10 and the 1, and you'd get 11, and the 9 and the 2, and you'd get 11, and the 8 and the 3, and you'd get 11. 7 plus 4 makes 11, and 5 plus 6 makes 11. That would be a perfectly legitimate way of doing it. You'd have 1, 2, 3, 4, 5 sets of 11, which makes 55. Or sometimes you see a pattern that you just like better. Like for me, I think counting with tens is really simple. So what I would do instead of that is I would make my arcs of my rainbow connecting everything that adds up to 10 and then marking the things that are left over. So for me, I would have done this. I would have said 10, 20, 30, 40, 50, 5. Either way, both ways work. They get you the same answer. Sometimes problems are written like this. They haven't given you the set of numbers. You're going to have to generate it yourself. In this example, it says find the sum of the first 8 multiples of 7. So if you know what a multiple is, that's fairly easy to do. And these are the first 8 multiples of 7. 7, 14, 21, 28, 35, 42, 49, and a little squinched in there, 56. Now if I were going to add these, again, I'm just going to draw my little arcs. So I get 7 plus 56. I get 14 plus 49. I get 21 plus 42. And I get 28 plus 35. So another little trick when you're doing this, maybe just like the mental math of 49 plus 14 is difficult for you to do. All of the arcs are going to add up to the same thing. So find the combination that's the easiest. Maybe find one that doesn't require you to regroup. So for example, 21 plus 42 is pretty straightforward. It's 63. That means all the rest of these add up to 63. We have 1, 2, 3, 4 groups of 63. So that means I have 4 groups of 60, and I have 4 groups of 3. Now I could do 4 times 63 if I know how, or I just could think, I know 4 times 3 pretty easily is 12, and 4 times 6 is 24, but I'm really multiplying it by 60, so it's 240. And then the mental math of this becomes very easy. 240 plus 12 is 252. And look how quickly we added up that set of numbers. Finally, you might see problems presented in this way. Find the sum of the following set of numbers. 3 plus 5 plus 7 plus ... plus 13. That ... is called an ellipsis. In math, an ellipsis means to just fill in every number that's missing according to the pattern. So here I've got 3 plus 2 is 5. 5 plus 2 is 7. So 7 plus 2 would generate a 9. That's missing up here, but I'm going to put it in my set down here. And then 9 plus 2 is 11. Again, missing up here. So I'm going to put it down here. Plus 13. So these are the numbers we need to add up. 3, 5, 7, 9, 11, and 13. So I'm going to do a quick rainbow. And what I have is 3 sets of 16. 3 sets of 16 is 48, so I know that these numbers add up to 48. Now, to be quite honest with you, I don't always draw the rainbows. I don't always have colorful markers. I don't always care to draw the rainbows. Sometimes I just use my fingers to point at things and try and keep track. So here's an easy set of numbers to do that with. If I needed to figure this out, I would probably just put one finger on the 1 and 1 on the 8. And in my head, I know that that makes 9. So I'd have 1, 2, 3, 4 sets of 9. 1, 2, 3, 4 sets of 9. So these numbers very quickly I can see add up to 36. This has been another episode of I've Got Problems. And now, so do you. Check the materials section in Schoology. See you next week.